Hello friends, so already we have discussed about the digital numbers and how digital number different kind of the binary number, octal number, BCD number, gray code. This number related all the types we have discussed, right? So now come to the main digital circuits. Okay, so whatever input we have to give in the digital circuit, these different kinds of the different types of the input we have discussed and during last 4 or 5 lectures, right? So here I will discuss, I will start with the digital electronic circuit. Okay, so if you think about the any kind of the circuit and system, okay, so any kind of the system or circuit, suppose it is one kind of the circuit or system. So inside this system, so system means what? System means if you give any input, you will get output. That output is the modified form of the output. Okay, modified form of the input. Right, inside this system, so many blocks are there. Okay, so many blocks are there inside this system. Okay, so these blocks are internally connected with each other like this way. Okay, so these are called the integrated system. Okay, these are the integrated components which are associated inside the system. Okay, each components are associated with the digital circuit. Okay, each component are associated with the digital circuit or digital gate. Okay, so we in a one application, if we need some kind of the you have some kind of the inputs, you need different kind of the output in a one application, for one application. Okay, suppose if you give a practical example, right? So you want to turn on the switch, but you can turn on the switch either from the one room, this room, or you can turn on the switch from another room also. Okay, so in the two different rooms, two switches are there. So if you turn on any one switch, the light will be turned on. Okay, so such kind of the application we can so for that we need one circuit. Inside the circuit some blocks should be there. So that means if we give, our requirement is some inputs, right? So I am giving some inputs and some feedback, some data we are feeding to the system. Accordingly the light will be turned on. Okay, so the output of the light, that is the light, it is blinking. Okay, so it is the output. Whatever things we are giving from our side, these are the inputs. Okay, so what are our requirements? Based on the application we can give some inputs. Okay, so based on those inputs we can get a modified output from the system. Okay, inside the system, so different kind of the gates are there. Okay, gate means circuits. Gate also consists of multiple circuits. Okay, so based on the structure of the circuit, we can get a different outputs for different gates. Okay, now here I will discuss first start with the what are the gates are available in digital circuit. Okay, what are the gates are available in digital circuit? So different gates are used for different applications. Okay, so first is the NOT gate. NOT gate or inverter. Okay, so what is the first what is the output? Suppose I am giving one input. Okay, so in case of the digital values, either two values are there, either it is 0 or it is 1. So first I am writing as 0 means it can be considered as a false. 1 means it is considered as a true. Okay, so for case of the NOT gate, or it is acting as a inverter. Okay, for case of the NOT gate, if you are giving false as a input, you will get true as a output. Okay, or if you are giving true as a input, false as a output. Okay, this input if you give, you will get this output. If you are giving this input, this you will get as a output. Okay, this is the NOT gate. Okay, so if I have some data, so I need some kind of the results which is inversion of the input data. Okay, for this application I have to use the NOT gate. Okay, and normally single NOT gate is normally not used. okay, for different application. We need some kind of the application, so along with not gate, some other gates are used normally for implementing such applications. Okay, the symbol of the not gate is like this way. Okay, so if you give 1, so you will get output. If you give 0, you will get 1. Okay, this is the triangular and dot. This is the symbol of not gate. So suppose you are giving input A, so this input is the A. What will be the output? Output is equal to A. This is called the A complement. So the inversion of the A. A is the input. The output will be inversion of the input. A complement. So what are the inputs you are giving, and accordingly what are the outputs you are getting? So this you can write in a one tabular form. Okay, that is called the truth table. Okay, possible input and output combination for a particular gate we can write in a tabular form. This is called the truth table. Okay, so possible combination of input and output we can um, write in a tabular form for a particular gate, that is called the truth table. Here you are getting on input, here it is output. If it is 1, output will be 0. If it is 0, output will be 1. Input I am writing in that side, output is in that side. Okay, and now, so next, so for that, 7404 is the IC number of the NOT gate. What it is? Okay, so if we write the symbol of the NOT gate, that is the triangular shape that I told. Okay, but when you think about the hardware component of the NOT gate, hardware means the practical implementation. Okay, so some kind of the IC are there. IC means integrated circuit. Okay, so all the normal digital electronics gates are under 7-4 family. Okay, 7-4 families, right? This is in one IC. There are the 7 pin in this side and 7 pin in that side. Okay, so 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so inside this is the 7404. This is the IC number. Integrated circuit. Integrated circuit, inside this block. Inside this block, there are the six inverters are there. Okay, 6 inverters. So this is, I have to connect with the ground. Any system you have to connect with the VCC and voltage common collector. Okay, and ground. Okay, so this if you want to if you want to activate any kind of the system, you need the positive power supply or negative power supply. Okay, so for that, ground and positive VCC. This means negative, this is means positive. These two power supply you have to give, right? So here in this component, there are the total 6 inverters. Okay, like this way. Okay, 1, 3, 5 are the inputs and 2, 4, 6. In this way, 6 gates are that side. 6 gates in this side and 6 gates are that side. Total 6 NOT gates are there inside this 7404 IC. So for a particular design, you can use the 6 inverter from this IC. Okay, 7404. So in some system, you need only one NOT gate. So you will use only one NOT gate from this 7404 IC. Okay, next is the AND gate. Okay, next is the AND gate. Okay, so here, so first I am writing the symbol of the AND gate. This is the D shape and 2 inputs. Okay, for case of the AND gate, 2 inputs are there. So it is called the AND gate. What is the output? A dot B. Okay, this is called the logical multiplication. Logical multiplication. Okay, so for case of the, what is the normally, if we want to write the definition of the AND gate, so that means if 2 inputs are true, output will be true. For other cases, output will be 0. If both the inputs are true, okay, you will get true as a output. Suppose if we turn on, suppose in one application, okay, you have to turn on different both switches, so that the output, you will get some output. Suppose you have to, for turning on the light, you have to turn on the both switches. Okay, That one is suppose motor, another is some other thing. Okay, so if you turn on both the switches, you will get output. Other cases you will not get output. Okay, so some doorbell and is there. So suppose when the doorbell will ring, so when in some person is there, the sensor will detect it. That will be the one output, and after that the bell is rang. Okay, if a human is there, that is the one output. Presence of input is a one output, and if you press the bell, so that is a presence of input. Human is one input, and if you press the bell, that is another input. So you will get a one kind of the, so that's, so if both inputs are true, if both inputs are there, then you will get output. The bell will be ring. Okay, this is the logic behind the doorbell system. Okay, so A dot B, logical multiplication. If both inputs are true, you will get true output. Okay, true output. Right. So 7408 is the IC. So I'll draw the, so in this 7408, I see 4 AND gates are there. Okay. So I am writing the, this is the circuit diagram, this is the logical expression, this is called the logical expression. So it defines a logical multiplication. A dot, dot means multiplication in case of digital. So what is the truth table? Means how many possible inputs are there and how correspondingly how many outputs are there. Okay, so if two inputs are there, so what is the formula? If two inputs are there, how many input combination you can give, okay, to the AND gate, right? Suppose that is as the digital is related to binary only, so this is binary means 2, okay, two inputs are there means 2 to the power n. N is the number of inputs, n is the number of inputs. Okay, for this AND gate, your n is equal to 2. Okay, so that means 2 to the power 2 means 4 combinations are there. Okay, so if binary number is, so in case of the binary, formula is 2 to the power n. Why 2? Because it is the binary system or digital system. So n is the number of inputs. So in this case, how many inputs are there? 2 inputs are there. So how many combination you can write? So total 4 combinations you can write, combinations of input. Okay, input. So how will write? Okay, so 4 means if you divide 4 you will get 2. So under that way I am writing 2 0 and 2 1, 4 combinations. So I am dividing 4 by 2. Okay, so you will get 2, right? 2 0 2 1. So 4 means 2 plus 2, 2 0 2 1. Then this 2 0 can divide as a 0 1 0 1. Okay, in this way you can write the total 4 combination. Now if you write the decimal number of this corresponding binary number, this is your 0 1 2 3. Okay, so 0 0 0 1 1 0 1 1. So that means if two inputs are, both the inputs are true, if both true means 1. Okay, if both the inputs are true, you will get the true output. For other cases you will get the false output. True means 1 and false means 0. Okay, this is about the AND gate. Now come to the OR gate. Okay, so for OR gate, if any, for two input, okay, two input OR gate, okay, if any input is true, output will be true. Okay, that means so we have two input switches. Okay, so if you turn on switch from any room, the light will be turned up. Okay, so this is the logic behind the OR gate. Okay, so if any input is true, you will get the true output, right? So for OR gate, the symbol is like this way. This is A, this is B, this is A plus B. So this is called as logical addition. Okay, logical addition. That means if any input is true, you will get the true output. This is called the logical addition. Okay, so this logical addition and binary addition both are different. For case of the binary addition, I will tell later this thing. Okay, now 7432 is the IC number for OR gate. Okay, inside these 4 OR gates are there. Okay, 4 OR gates are there. Okay. So for here also 2 inputs are there. How many combinations? 2 to the power 2. 4 combinations you can write for OR gate also. So A and B, and output is 1. Okay, so how can I write 0 1 1 0 0 1 0 1 1 0 1 0. So if any input is 1, output will be true. If any input is 1, output will be true. If any input is 1, output will be true. Okay, if both the inputs are not true, output will be false. If both the inputs are false, then output will be false. If any input is 1, among in these three combinations, if any input is 1, output will be 1, right? So this is the rule. So here you can see, this is the logical addition, A plus B, logical addition, binary addition. In case of the binary addition, if you remember, in case of the binary addition, if you add 1 with the 1, you will get 0 as a sum and carry will be 1. This is your sum, carry will be 1. 1 plus 1, the result is 0 only. But for case of the logical addition, 1 plus 1, result is 1. Right? This is about the OR gate. Okay. Now come to the NAND gate. Okay. NAND gate. Okay. NAND means what? AND plus NOT. Okay. That means inversion of AND gate. Okay. So I am just drawing the circuit diagram. This is the and along with this NOT is there. So this is equivalent to, if you remove triangle only, you have to put dot. This is your NAND gate. 7400 is the IC number for NAND gate. Okay. A, B and this is your Y. Right. So for case of the NOT gate, that complement of the input. So for NOT gate, what will be the output? Suppose here it is A and B. Here you will get A dot B. The complement, this is AB is the input of the NOT gate. So complement, okay, complement of the input. This is A dot B. So that means this is the logical expression for NAND gate, complement of the logical multiplication. Right. Now, so from this formula I am writing the truth table. So in case of the AND gate, what you got? In case of the AND gate, for this combination you got 1, right? Suppose here I am writing A dot B, here I am writing that is A dot B prime, okay? AND gate output is what? 0, 0, 0, 1, okay? Complement of 0 means 1, 1, 1, 0. So that means if both the input are true, output will be 0. Both true, output false. Okay. If both the inputs are true, output will be false. Or other cases, output will be true for case of the NAND gate. Okay. That means just complement of the AND gate. Okay. If you remember the truth table of the AND gate, you can get the truth table of the NAND gate. Okay. Now, next is the NOR gate. Okay. Next is the NOR gate. NOR means OR plus NOT. Okay. First I am drawing OR gate. Okay. Here it is NOT. So A, B, A plus B. Here you will get A plus B. Here it will be A plus B complement. That is equivalent to this one. Okay. A plus B prime. 7402 is the IC number for NOR gate. Okay. So here also same 4 combinations are there. So first I am writing A plus B. Now I am writing A plus B complement. This is the output of the NOR gate. Okay. For OR gate, if any input is true, output will be true. This is the output of OR gate. Just complement this each number. This will be 1. This will be 0. That means if both true, okay, output will be, so if both false, If both false, output will be true. Okay, if both false, output true. Okay, so this is about the NOR gate. So again, if you remember the truth table of the OR gate, you can get the truth table of the NOR gate. Okay, that's complement of the OR gate. Last is the XOR gate. Okay, last is the XOR gate. That is little bit different. Okay, XOR gate. Okay, so for XOR gate, this is the symbol for XOR gate. If A, it is B, logical expression is A, put a cross and circle it, that is B. Okay, so what is the logic behind XOR gate? If both inputs are equal, okay, output will be 0. Both inputs are not equal, okay, output will be 1. Okay, this is the logic behind the XOR gate. If both inputs are equal, your output will be 0. That means if both either it is true or it is false, don't worry. If both inputs are equal, output will be 0. If both inputs are not equal, output will be 1. So I am writing now truth table. Okay, this is the logic. Okay, this is the logical symbol for XOR gate. A cross and circle it B. Now, how many combinations for 2 inputs? Total 4 combinations, right? That means if both the input, here both the inputs are equal, output will be 0. Both the inputs are equal, output will be 0. If both the inputs are not equal, in those cases, both inputs are not equal, output will be 1, 1. Okay? So, this is the truth table for XOR. This gate is also used for some particular application. Okay? 7486 is the IC number for XOR gate. Right? So if both the inputs are equal, output will be 0. If both the inputs are not equal, output will be 1. So by consideration of this definition, we can write the truth table for XOR gate. Okay. So next class I will again proceed with some properties of the Boolean expression. What is the Boolean expression and properties of the Boolean expression, and what are the universal gate. This I will discuss on next class. And kindly subscribe my channel and even and like and share also. Thank you.